everyone, good morning. We're continuing solving equations involving logarithmic functions and exponential functions. I think we finished number 3 yesterday. Hopefully we'll finish this today and maybe start a little bit of next section, 4.6. Basically what we need to do in an equation solving involving exponential functions is you need to get the exponential term or exponential expression part isolated. So you need to first identify what's raised into power, such as in this question everybody can easily spot this is the exponential part, right? That's the part that has exponents, and we need to get it isolated. Once we get it isolated, we are going to choose an appropriate logarithm. This is your choice. You choose one logarithm. It says same base as the exponential, but I gave you the flexibility that you can use common logarithm base 10, or you can also use ln. Okay, so you can use 3 logarithms, either the same base, common, or natural logarithm. Take logarithm and it's going to bring this exponent down on the ground, and then we are going to isolate the variable and bring everything else to the right side, and this way we solve it. And if they want us to approximate the answer, we will use a calculator to compute those logarithms, unless you can compute it manually with hand with simple, if they are simple enough. Okay. Alright, this was the last thing we did. Pretty simple one comparing to our new question. Only one exponential, already isolated, set it into a number. This is a little bit more work because you need to get this by itself, but it's not too bad. All you need to do is bring this 9,700 from left to right. Simply either flip the sign or add both sides. 9,700. Okay, so that will take care of it. 10 raised to the 4 plus 3y equals, what is 9,700 plus 116,000? 125,700. Is that true? Okay, that's step 1. Step 2, we are ready to take the logarithm. So which logarithm do you prefer here? ln? Do you want to take ln of both sides? No, this is already base 10. You either choose the same base or common or ln logarithm. This is already 10 and it's already common logarithm. So we will go with log of both sides. Okay, log means base 10. If I don't put any base to it, it's base 10. Okay, next, why are we using logarithms on each side? What's the purpose of this? You shouldn't be doing anything without a purpose. What's the reason for this? Why did we do this? If you know it, let me know. Why are we putting logarithms to both sides?
So you can bring down the exponential.
Yeah, logarithms have a great property called bringing down exponent property, or power law I call it. It takes any power on the exponent of a base into in front right here. This way the variable you're looking for, 4 plus 3y, is on the ground so you can isolate it. Otherwise on the top exponent, like it's locked up in this prison, you cannot isolate y. Okay? Alright, what is next? We need to solve now the resulting equation. Oh, by the way, we could have done one move and we could be done with it, but I will do it separately. Now I need to get y by itself. 4, 3 and log 10 should disappear. One of them already actually disappears automatically. Which one? 4, 3, log 10. Log 10, log has a secret base 10. 10, 10, if matches, it's 1. Actually, we should have done it right here. Log 10, since it's base 10, 10, cancels, and this guy falls to ground without move. You don't have to move in front, okay? Okay? So they cancel, and 4 plus 3y is on its own. Alright, we're almost there. I need to now get rid of this 4 and divide both sides by 3. And we're all set. Alright, before attempting to use a calculator, I tried to compute this logarithm by hand by simply, like, these things can be computed because 1000 is 10 cubed and this is already base 10, so this just becomes 3. Is there any chance you can make 125,700 into a power of 10? This way this 10 and that base 10 can cancel. Is there a way? 1000 can be possible, 10,000 can be possible, 100,000 can be possible, 125,700. I can't. I don't see a power of a number here on top of my head. Okay, so this is our exact answer. I can't simplify it more. That's what we are gonna enter into the first part. So that's log, back up to use the fraction first. Okay, this is what we're gonna enter here. And they will ask us to compute as much as we can this logarithm. And at this stage, all you need to do is key in this thing into your calculator. So let's use here. Log 125,700 minus 4 over 3, right? Well, you can't do that. There we go. 0.3664. How many digits do they want? Up to 4 decimal values. So take the 5th decimal and round it down or up. This is 4, so we round it down. 3.3664. Okay. Any questions? Alright, moving forward, we have another exponential equation. However, what's the difference between 5 and 6? Basic difference when you compare them. Compare the equations. Do you see a difference? Both sides have a different type of exponents. One with a base 10, one with a 3. Now what shall we do here? Forget about isolating exponential on one side. You can't, because there are two exponentials with two different bases. So what we are going to do is we are going to isolate them, one on the left, one on the right. It's already been done for us. There is nothing else besides those exponential expressions. There is no numbers next to them, thank God. It's going to complicate things. It's only one on the left, one on the right, already been isolated, kinda. Okay, now we are gonna choose a logarithm and take logarithm of both sides. However, you have options here. You can choose some base of both sides, but what base are you gonna choose? Are you gonna go with 10? Or, wait a second, I see 3. Are you gonna go with 3? Or are you gonna go with base E, in other words ln? You have 3 options: 10, 3, or ln. Or maybe this is a better idea. Are you gonna go with 10 and on the left side and 3 on the right side? 4th option. Okay, here are your options: base 10, base 3, base E ln, or mix 10 and 3. 4 options. How many of you guys support number 1, base 10? Base 3, ln? So, how about mixed order? Anyone going with mix? Alright, this is ridiculous. I was just testing you, tricking you guys. You cannot choose one side a base and another base on the other side. Impossible. I mean, this is gonna break the balance between equations. You are not applying the same thing to both sides. It's not correct. So go with the base of your choice. I don't care. It can be 10, it can be 3, or it can be ln. But I will go with 10 or ln. 3 is the worst choice. It works. You can put 3. It works. But your calculators won't be able to compute logarithm base 3. And then you need to make a change of base operation on the end. If you go with this option, you're gonna prolong your solution unnecessarily. So avoid using these bases other than 10 or ln. So I will go with ln because it looks like everybody likes natural log better, not base 10. So I'll put ln and ln on both sides. Well, can I do this now? Can I say these are canceling and we get 1 minus 6x and 5x minus 3? Can I? No, because ln has base e. This is 3. They are not matching. So you can't cancel them, but you can at least move these guys in front. Okay? So it's 1 minus 6x times ln 10 and 5x minus 3 times ln 3. Alright. ln 10 is nothing but a number. This is a number, this is a number. A number multiplying a parenthesis, a number multiplying another parenthesis. To be able to collect those x's together, bring those x's together, unfortunately you need to multiply these parentheses out. So 1 times ln 10 is ln 10 minus 6 times ln 10x, okay, equals 5 ln 3x. I will keep this in parentheses so you don't confuse x inside. X is not inside. And 3 ln 3. Just ln's a number, ln10 and ln3, moves as a block. You cannot separate them, or you cannot multiply 5 and 3. Okay, next, remember, we need to bring x's together, and I see two spots with x's. 1, 2. They need to come to the same side. Which side would you move them? I don't like negative variables, so I want to add both sides this. I want to move x's to the right. Okay, and this way, these two cancel. And I want to bring the numbers to the left side, so I'm adding both sides 3 ln 3. So on the left, I have 3 ln 3 and 10, these two, equals 6 ln 10 x plus 5 ln 3 x and nothing else. Make sense? Are you with me? Okay, remember, we need to get x isolated. Now I have two x's. We need to first add up these x's. Just like if you have 5x and 2x, you add them and make 7x, right? These are numbers. So you can add these numbers and collect those separate x's into one x. Again, I can collect into one x, and these guys move in here. 6 ln 10 plus 5 ln 3. I'm kind of factoring out x's. These are common factors. I'm factoring it out here. Okay? Whoa, what a mess, isn't it? Alright, how do I get x alone now? Divide both sides by this. And finally, alright, that's it. We got x as 3 ln 3 ln 10, 6 ln 10 plus 5 ln 3. There is, if you wish, you can bring this 3 inside as a power and combine these two separate logarithms into one big fat logarithm, but it's not necessary. You can keep them separate. Then it's gonna be, I think, ln 270. Look, when this guy goes in here, ln 3 cube, it becomes ln 3 cube, right? Which is 27. And when you multiply 27 and 10, these two combine ln 270, because addition turns into product rule. Okay? But it's optional if you wish to do it. It's just gonna look nicer on the top. And you can combine these, but this is ln 10 to the 6th, 1 million. This is 3 to the 5th, what is it? 243. So it's 243 million ln. It's a mess. But this is it. I think this is gonna work in the answer box if you put it just like that. It's gonna be hard to type in though. I already forgot. ln what? What was it? ln 10? No, what was that? I already missed my spot. It's hard to type without a mouse, proper mouse. 3.
Yeah, there's a...
Oh, I'm doing the wrong question. What question is this? Oh yeah. things. ln what? All right. Correct. Now, what we need to do is take this and put it into calculator. ln 270, it was the top. I just want to cheat them, combine them. And ln 125 million. No? Yeah, 243 million. Alright, it looks like 0.2899. Yep, I was right. How did I get those numbers again? I combined these LNs because they are hard to type in separately. Again, this is ln 270, and this is 10 to the 6. 10 to the 6 is a million, and this is 3 to the 5th. 3 to the 5th is 243. When I multiply them, it's 243 million. But if you write them separately, still your calculators can do it. I just don't want to mess with it. Alright, and next question. This is kind of a weird question. It's kind of trickier than what we done previously. There is no way I can isolate. I didn't put these steps here because there is no way you can isolate exponential expressions here. Look, I have two exponential expressions, one here, the other there. And even though I separate this to the right side, there is no way I can isolate each because this 24 and 10 won't go anywhere, right? So I will have one expression on the left. This is the left one. This will go to the right, but this 10 and 24 will still be around them. So no matter what I do, I won't be able to isolate them. So all these steps are void now. It's not gonna work. So we are gonna use something smarter, and there is a pattern here. There is a relation between these two. Alright, let me give you a hint. E to the 2t, can I write this as e to the t to the power second power squared? Does it work? Or am I just making that up? Are these two things equal? Is e to the 2t the same as e to the t second power? Some people think this is t squared, but now when you look at them, they're actually next to each other. It's 2t. They are equal. But if you have x to the n and another m, you multiply them n times m. Correct? Like if you have x squared cubed, it's x to the 6th. 2 times 3 is 6. I just did that. Now what do you see? Look at this. Same color things. And let's choose this a different color. You have the same e to the t showing up in both spots. Do you see? E to the t, e to the t. This brings me an idea. I don't like e to the t's. It's just personal issue. E.T. Have you seen that movie? Okay. That movie gave me nightmares. I don't like E.T. Okay? So I want to call it a different name. I want to call ET a different name. What do you want to call it? Can I make that ET choose something? U, X, Y, if you any letter. Now imagine I make those ETs U. What do you have now? U with a square minus 10. Let's call this green U so you can see better here. Minus 10. Oh, same ET, then same U. Minus 24. Do you see what trick I did? Do you see the trick? Just the ugly looking, scary looking ET monster turned into beautiful variable we've been working all life, right? This is a quadratic equation now. Square equation. And you know how to solve these very well. How do we solve these really? We factor them. Best way is if you can factor them. If you cannot factor, use quadratic formula minus b plus minus b squared minus 4ac, that thing. Use that quadratic formula. Alright, I believe you can factor this. Two numbers multiplying into minus 24, adding to minus 10. Minus 12 and 2. First thing came to my mind was 6 and 4 to make 10. Yeah, it's positive 2, but minus 6 positive 10, I'm sorry, 6 and 4 will never make minus 24 and 10 at the same time. 12 and 2 is the right one. So we got two solutions. U is, now we set each into 0. We get U equals 12, U equals minus 2. Are we done? Can we go ahead and say the solution is 2 and 10, 12? You can try that. But what do you expect to get? 12 and minus 2 and 12? I'm not even checking this. This is incorrect. Why?
Because you have to change your names back in the
Right. These two values are for my made up values. I made up this value variable. They didn't ask for it. They want what is t. They are looking for t again. Look, what's the original variable? You need to present your answer in original variable. So you need to change that u back to whatever it was, and it was e to the t. So put it back here. And we need to get t by itself. And how do I get t isolated? It's on top of an exponent. It's above a base. How do I get t by itself? And they are expecting t equals something. Now we are using this. We bring exponential on one side of the equation. Yes, it's on one side alone. Then we are gonna take log of the same base of both sides. So we take ln of both sides. And I get these two cancelled. Cancel, cancel, and t is the only thing left on the left side. T is ln 12, and t is ln negative 2. Alright, somebody needs to stop me and make a comment here. What comment can you make? You got two results. Shall we enter them? Do you want to? Right. When we are exploring domains of ln, logarithmic functions, they were rising like that, right? On the right side of the xy axis. That means on the positive x values, domain of logarithms can never be negative. As a matter of fact, you should have warned me right before that. You shouldn't have waited this long. When I raise e to a power, any power, exponential functions are always above x-axis, positive y values. They can never become negative. Right? E to the x is rising like this. It's never under x-axis. It's positive all the time. So this is impossible. We could have stopped right here. This cannot happen. So there is actually a single solution, ln 12 here. Alright, approximate solution, you just need to enter this here and get up to 4 digits. 24849. Alright. Any questions? Alright, tricky question, but it wasn't too bad. Once you figure it out, smooth computations. Now, we're right in the middle of this section. We have solved so many questions about exponential functions, exponential terms. Now we will see equations with logarithms. How do we take care of logarithms? Alright, version 1, simple version. If you have only one logarithm on the left, another logarithm, same base, single logarithm on the right, you simply wipe them off and set x and y equal each other. So I see one here, one there. I just make them disappear and solve that way. It's so easy. If you have already one on the left, one on the right. Bring w's to the right and numbers to the left. Okay? All done. What? What did I do wrong? Oh, okay, okay. I have missed a very important part. Alright, one trick about logarithmic equations is the solution you got may be fake. Maybe a bad value, your logarithm may fail to act on it. So all you need to do is, once you get the answer, go back, clean your work here, and substitute only, if you don't want to go all the way to the end, see equality, substitute and see what happens to inside of logarithms. See if it becomes negative, because once the logarithm is negative, you cannot compute it. Alright, let's take a look. No, this is working fine, right? Is it? Let's see. 4 minus 5, which is 9, logarithm. I made a mistake somewhere.
You subtract 16 from regular form, minus 27.
Yeah. So this is no negativeness issue. It's all positive, right, when I enter it. The problem is they're not matching. So I made a mistake. So that mistake is, why did you guys wait? So you wanted me to fail? Okay, -3 is the right answer. But what I said is correct. We should always be aware that if you get your answers, they may not be automatically satisfying it. Sometimes they make the inside negative, so you need to pick them out and don't put them in here, okay, in the solution set. But this one was safe. It's just my calculation mistake, not domain mistake. Well, we're gonna do the same work. However, we have a problem. You don't have a single logarithm on either side. Remember, the key thing is we need to have one log on left, one log on right. That's it. How many logarithms do you have on the left? How many? 2. So we need to combine them first. About the right side, shall we do anything about the right? No, it's perfect. It's already 1 log. So step 1 again, we need to isolate the logarithms on one side of the equation. Okay? And I see 2 here, they are not isolated, so I need to keep them single here. Okay, how do I combine them? How? If there's a plus between logarithms,
The product property.
it turns into product, yes. You multiply the stuff inside. Okay? And guess what we're gonna do next? Do you have 1 on the left and 1 on the right with same basis? Alright, then cross these out and get x minus 8 equals 7x minus 54. Alright, all you need to do is multiply these out, bring x's together. Since this is a quadratic equation, I brought everything to the left. I brought 7 and 54 to the left by flipping their signs. I multiplied this out, x squared minus 8x, because I like everything on the left because I want to factor and set each into 0. So we have these two combining to make minus 15x. Now guess 2 numbers. Their product is 54, but their sum is minus 15. What 2 numbers is that? Good. 9 and 6 with negatives. So you get x equals 9, x equals 6. Alright, validity check. I need to check whether these answers gonna work in these. And as I told you earlier, some of them may make my function sick or broken. They are not in the domain. Look, enter here 6. Does it work? Do we always have inside positive? Do we? Let's just check. I can compute ln 6. How about ln 6 minus 8? Negative 2. Can you compute an ln negative 2? No, this thing is not on the domain. Not on domain. So we cannot take this. How about 9? So back up and try 9 now. Can you compute ln 9? About 9 minus 8? Yes, it's positive 1. Perfect. About 7 times 9 minus 54? 63 minus 54 is 9. So it works. You can even compute this. ln 9, ln 1 is 0. ln 9, ln 9 match, you see? So it's actually, can go all the way and show that x equal 9 verifies our statement, our solution. So the solution set is a finite set, not all real numbers, not empty set, but a finite set. We had only one. Finite means limited, and that is 9, correct? So don't be surprised that, oh, I found two solutions, everything checks out here, but why ConnectMath is not taking my answer? Because one of them is a fake answer, okay? It's not correct. Alright, let's go for this one. This one is trickier. I'll give you a minute to think about it. Okay, my earlier trick, let's try earlier trick. We need to get these isolated. Do you see only one log on this side? One log. Do you? This side checks out. Do you see one log completely isolated on this side? I see one log, but it's not being isolated. This is nasty, bad. A single number they put in there is messing up my entire plans. Okay? What shall we do? Alright, there is an option you can make, but it's too long. You can make this a log, turn this into log, and combine these two together and make my earlier method work. You can turn 2 into a log. Do you know that? 2 is actually logarithm base 662, isn't it? Can I write it like this? Look, isn't this true? 2 equals this. So I can make a big base 6 log with 36 inside. This is 36 inside, and I can combine these and make my earlier work okay. However, I'm not gonna do that. I'm gonna show you another trick. If there are nasty stuff next to your log and you cannot isolate it, then you need to bring all logs to the same side. Don't keep them on separate sides. We need to bring all logs to the same side. So what do you want to do? I want to bring this guy to the left and get the number isolated, and logs come together on the left and they become isolated as well. So when I take that logarithm to the other side, turns into plus sign. We have log 6t plus log 6 of t minus 9 equals, look at this, only a number 2. Now you have 2 logarithms here, and we expect to see an isolated logarithm. So we need to get these 2 combined. How do I combine them? By, this is product rule. By multiplying those 2 logarithms, making one logarithm only. Only we multiply the insides. Okay. At this stage, you have 2 methods you can do. One is what this method proposing. I will do the method one explained here. The second method, you may like that also as well, is actually I give you a preview. I'm gonna do that trick as well, but let me first finish this. This is now circle, box, triangle combination. Way back the first day of logarithms. When I give you a logarithm, set it into number, you can rearrange these three geometric objects, circle, box, triangle, into an exponential. That's what it says. Write the equation in exponential form. That's why we spent so much time on this. We solved 3-4 questions just like this so that you can get used to it. Now you should be proficient. Can you rearrange these into an exponential? Again, base, this is the trick. Base of the logarithm, still base of the exponential. All you need to do is put red box and green triangle into here and there. You have 50-50 chance. Where does 2 go? Base is still base. That's true. All you need to do is choose 2 on the left or right. That's it. Where? On the left side. Free guy goes to prison, goes to tower, prison, and the locked up person earlier in logarithm goes free. We have 36 equals t squared minus 9t. Alright, we need to solve for t now. What kind of equation do you see? Look, identifying the type of equation is half solving it. Don't try to attempt a solution quickly. No, identify it first. Do you see several spots with axes? And if one of them is a square, it's called quadratic. And quadratic equations must be set into 0 first. Everything should be collected on one side. So you can factor them. So I'm going to take this 36 to the right side and set this into 0 that way. This is the third time today we're doing this. In the previous question, it was a quadratic as well. Every time we brought them, collect them on the same side and made 0 factor. And we made it, no, we didn't make it here. This is a linear one, it's not square. But I think we done this previously as well. So same trick all the time. Get the variables and numbers on the same side because it's quadratic and factor. Alright, somebody help me. What values? Multiply to 36 minus 36. Add to minus 9. Minus 12 plus 3. T is 12. T is minus 3. Okay? Alright, one of them should be fake. Which one is fake? Of course, negative 3. Right? Why? Just plug in negative 3 here. Can you compute logarithm of negative 3? No. This is a fake one. Alright, I promised you a second option right here. So can I clean this? Is this clear? So I'm going to make another option. If you don't want to change this into exponential, if you don't want to follow these directions here, then here is your option. You can still use this fact. All you need is one logarithm on the left, one logarithm on the right. Oops. Alright. All you need is one logarithm on the left, one logarithm on the right, so you can cross them out. But I don't have a logarithm here. Can you turn 2 into a logarithm with the same base? How can I write 2 as a logarithm of base 6? All you need to do is put another 6 here so they can cancel, and put this 2 on top of it, so when you cross these out they can cancel, right? Agree? So 2 is actually logarithm of base 6 of 6 squared. So can I put it right here? Instead of 2, I'm making it base 6 squared. Now guess what? I have one of each on the left, so I can cross them out. And I get t minus 9 is 6 squared, which is 36. And bring this to the left, we get the same equation. Isn't it the same thing? Rather than making exponential directly, I just made an exponential here and cross off logarithms and went that way. So it's your choice at this stage. Okay? Now, last question we're gonna do in this section is an application. And guess what? We will continue these applications in the next section as well. So this is kind of a good transition. We're gonna finish off with a word problem, and we'll keep working on word problems next from all kind of subjects. Radioactive decay, population growth, business models, interest is coming up next. Alright, but this is not new. This is something we have seen in the past. Do you remember these formulas? What was this one for? This is for interest computation. For what case? PERT. It's compounding. Both of them are compound interest. This one is monthly, yearly, semi-annually, minutely. You use this. So there is some time passed and you get the interest. This one is for continuous. Every split second, every moment you stop and compute interest, you use this. This is called time period compounding. Like you have some gap between the next two interest. Time period compounding. This is continuous compounding. What is the question here? You'll use either one and answer this. A is the future value of invested amount. Of course, we already know that. And rate is the how much interest they give you each year. N is the method of compounding, how many times you compound. Part A, you are investing $14,000. We know what P is. So this is your P. This is the amount you put in your bank account. And it grows into 18,000. So what is this? Which letter is this? N, T, P, A. This is what? A. So I know I'm investing this and it grows into this. I know both A and P. Now what is the question here? I bet they are going to ask one of the variables here. They have provided me the rate as well. This is the rate they are providing me. So I know R, I know P, I know A. I know it's quarterly compounding. This is N. So I know N. What is the only letter that doesn't have a check mark? T. They are asking, look, how long? This means time. How long did I keep this money invested? They are asking for T. Which formula are we going to use? Why are we checking this one in? Because I see it's compounded quarterly, not continuously. So we're not going to use this in this part. So we'll go with this. We know everything on this equation except T. So I will replace all those letters with the values. 18,311 88 is A, P is 14,000, R is, what is R? 4.5? That's how you enter it. And we divide this by 100, because it's 100 percentage, so it is 0.045. N is, what is quarterly mean in N? How many times do you see interest in a year if it's compounded quarterly? 4 times, 4 quarters in a year, right? And then 4 again, because it's N again, and then the unknown, how long is unknown, so it's T. You need to get to this T. Now, go back, look at this equation, please memorize this. Keep this on mind. Doesn't it look like one of the equations we solved in the past? Doesn't it look like this? Except instead of subtracting a number, you're multiplying this time. P, A, and a base raised to the power T. Kind of Y was question Y on the top was asked. Now they're asking T on the top instead of Y. So this is an exponential expression solving question. So this is an application of the first half. How do I get T alone? We need to first compute the base clearly and leave this isolated. But you need to clearly compute the base. There is a base here, base raised to some power. So somebody compute this base, please. Divide 45 by 4, add 1 to it.
1.0.
Okay. So it is 1.01125. Okay, is that right? Raised to the 40. Alright, to get this again, my task is the same. Isolate. I don't see it isolated yet. I have this nasty number in front. How do I take care of it? We cannot because it's not addition. We divide it. This is multiplication, so we need to divide both sides by that number. Okay? Now divide somebody.
1.307.
It's an exact number like this. I mean, it's not this ending.
No, it's 99.
Just give me. Yeah, this is actually earlier was fine because it's just nearest year. It doesn't ask for so many digits, so you don't have to put. But I just want to be cautious and put as many as I can. Alright, it's isolated now. We are at this stage. We've got it isolated. Now it's time to take log of both sides. What log you're gonna choose? What log? Which base? What's that? You can choose the base on the right. That's okay. So you can go with logarithm of base this weird number. However, eventually they will ask us to round off the t time in years, and our calculators won't be able to compute this. You need to go with the base change. So it's not a wise choice to go with this weird number. If your answer needs rounding off, go with the well-known bases like log base 10, common logarithm, or ln. So we like ln better, right? Let's go with ln. Otherwise, you need to go with the change of base formula to compute t. And this will bring this guy in front. And finally, we need to divide both sides by this so I can get t ln. Divide both sides with what? 4 ln 1.001125, so that we can get t all by itself. You need to divide by 4 as well. Okay? Alright, I need somebody to do this. Take ln of these numbers and divide them.
Point 0.0007.
Did you take 4 as well?
Yeah.
That's too little. It should be more. Because even if I keep 1 year at this interest level, it will grow on into like 15,000. It should be more than several years. Where did we do a mistake? Are we sure this is double 1 or 1, 2, 2? 6.745. This makes more sense. You need at least 6 years. And please also double check if we have double 1 here. Is it single or double? When did we get that number? 1 plus 0.045 over 4. Yeah, I think it's double 1. Yeah, we're good with this number. But we need to round this off to the next whole year, right? It says round to the nearest year, and nearest year is 7 years. You need to keep it for 7 years, right? 6.7. Alright, let's see if you're right. Incorrect.
5.6, because I just got 5.9.
You got 5.9? It's 6. Okay, but you kind of cheated. Let's double check. Tell me those digits, please.
No, 1.307.
307
991.
divide 4 times. Make sure you keep these in together. 4 times ln 1.001. 00. Thank you. Yep. Oh, where do we have 59 now?
I don't have a double zero. I don't have a double zero either.
It's just, yeah, it's just single zero
That's
then.
why, yeah.
5.996. Yeah, we'll be too old to wait for that, okay?
Yeah.
Alright, let's take squares of it. It's 5.99 something at 6 years. Alright. So, you need to have good calculator skills. It's nothing much. Yeah, there isn't much algebra, but again, be careful with these moves as well. Oh, when you come back tomorrow, we will do more of this type of work, a lot of calculator work. We will apply these formulas into real life. Population growth. What will be the population of United States, for example, in 20 years? That kind of stuff. Okay. See you tomorrow.